Paper 1, question 7, we've got two quadratic functions and it's saying that they touch at point P. They don't intersect. If they intersect, that would be, they'd end up intersecting twice. They just touch once at point P. So when they touch, that's when they're equal to each other. So we can write these quadratics equal to each other first of all. And because they are, we're forming a quadratic equation, when we're manipulating that, we're going to make it equal to 0. So we're going to bring everything over to the left-hand side, which is going to give me 2x squared minus 6x, and then plus 5 minus m is going to equal 0. So we've developed a quadratic equation equal to 0, and we can now think, well, when is that going to have one solution? Okay, so we're thinking about the discriminant, the b squared minus 4ac. Remember, when that is equal to 0, we will have one solution. If b squared minus 4ac was greater than 0, we'd have two solutions. If b squared minus 4ac was less than 0, so negative, remember in the quadratic formula we'd be square rooting that, and we can't square root a negative, we would have no real solutions. Okay, so the one we're interested in is when b squared minus 4ac is equal to 0. Okay, so remember, a in this quadratic is equal to 2. Okay, b is equal to negative 6. And c is equal to the constant, which is equal to 5 minus m. So what we do is we go b squared minus 6 squared minus 4, a, which is 2, and c, which is 5 minus m. That's got to equal 0. So we've got 36 minus 4 times 2 is 8. And I'll leave the 5 minus m there. That's 36. Expanding this out, 8 times 5, that's minus 40. Minus 8 times minus m, that's positive 8m. Equals 0. 36 minus 40. That's minus 4 plus 8m is equal to 0. So 8m is equal to 4 if we move it over, and m is equal to 4 on 8, or a half. Okay. So that's the value of m, but we need to determine the coordinates of point P. So we'll do that now. Okay. So now we know the value of m, we can sub that in to our original, the equation that we formed up here. And we've got 2x squared minus 6x plus 5 minus a half. So I'm going to go with plus 4.5 there, equals 0. And we want to solve that quadratic now. We could try and factorise it. But with that 4.5, it's going to be a little bit tricky. So I'm going to use my quadratic formula. I'm going to use minus b plus or minus the square root of b squared minus 4ac all over 2a. Now, there's not a lot of point worrying about what this is because we already know that that's equal to 0. That was the whole point earlier. So what we've got is minus b, which is minus 6, so 6, plus or minusing 0 over 2a. Now a is 2, so that's 2 times 2, that's 4. Okay, so what we get is 6 on 4, or 1.5. So we know that that is the value of x when they're going to touch. Now y, to work out, because it says coordinate, okay, so we can't just say x is 1.5, we need a coordinate. We're going to use either one of those quadratic equations. So I'm going to go with the x squared, the first one, minus 4x plus 5. And I'm going to sub in what x is. So that's 1.5 squared. Remember, this is paper 1, so we're going to have to do this without a calculator. but well, that shouldn't be a problem. 1.5 squared, that's like 15 squared, is 225. Let's put the decimal point back in there, 2.25. 4 times 1.5, 1.5 lots of 4 is 6 plus 5. So we've got 2.25 minus 6 and then add 5 and we get 1.25 for that. So the coordinate, let's go with that nice green again, of P is 1.5, 1.25. Let's put that in a box so that the marker can definitely see it. And that's the end of the question.